This is a reading of an Aristotelian dialogue concerning the geocentric and heliocentric cosmologies, Contra Galileo, which I am the author of, and which you can find a copy of in the archive and Amazon links below. This portion will conclude our strictly speaking cosmological focus of the argument, and will provide Galileo's response to the Aristotelian arguments that have already been stated, in which he was given time to regather his thoughts and provide a response to. Now, to briefly review, the burden of proof is on those who would have the earth be in motion in order to account for the risings and settings of the sun and the other luminaries. Since we plainly observe the sun and moon and fixed stars to rise in the east by a motion that does not appear to be that of the earth, but to be of the celestial bodies themselves, that we observe them rise in the east and set in the west. That means the burden of proof is not on the geocentric theorists who would have the earth be stationary and would account the observation of risings and settings of the sun and moon and fixed stars and planets to the heavenly bodies themselves as moving in circles around the earth, because that is what we observe very plainly and obviously. So then, the burden of proof is on those who would attribute the risings and settings and various other motions of the planets going through the zodiac to the motion of the earth. The burden of proof is on them. That is why they have to liken the situation, the cosmological situation about the placement and motion or lack of motion of these things. They have to liken the situation to an analogy of a sailing ship, in which a ship that is moving along a coastline, from the perspective of being on that ship, there is the apparent motion of the coastline moving in the opposite direction. With reference to that, those who would say that the earth is in motion say that the apparent motion that we observe, the apparent motion that we observe of the sun and moon and fixed stars and everything else rising and setting in circles around the earth every day, that apparent motion is attributable to the motion of the earth, that the motion of the earth can explain the risings and settings of the celestial bodies that we observe on a daily basis. That is why, again, the burden of proof is on those who would say not that the sun rises and the stars rise and the moon rises and the planets rise by their own circular motion or by the circular motion of the fixed stars, and that the earth is motionless. The burden of proof is on those who would say that the risings and settings and everything else, the transits through the zodiac of the sun especially, is to be attributed to the motion of the earth. And so they liken the situation to the analogy of a sailing ship, the earth being like the sailing ship that is really in motion and turning towards the east, revolving around its center towards the east in order to account for the apparent motion of risings and settings that we observe to happen once a day. and that the risings and settings of the sun and stars and moon and planets, that the apparent risings of the celestial bodies is like the apparent motion of a coastline, which from a ship that is moving along a coastline appears to be moving as a whole in the opposite direction. That is why Galileo says that if we are to investigate whether the earth is in motion, we must look for a motion that is common to all other bodies. And that if there is a motion that was only perceived in the moon with no effect on the position of Venus and Jupiter or anything else, then that motion could not be attributed to the earth, but must be attributed to the moon. Because the motion that we are looking for, the apparent motion, that would be the effect of the earth's motion, if the earth were in motion, would be the motion of everything else. And so, according to Aristotle, who hypothesizes the same thing in order to draw out conclusions and see if those conclusions are not contradictory, if impossibilities don't result. It says that the earth would have to move with more than one motion, because there is not just a single motion of risings and settings with everything holding the same relationship to each other. Rather, we find passings, we find planets passing others, we find the sun and moon with different motions than just the risings and settings. So the first motion of the earth has to account for the risings and settings. That is plain and simple. However, the relevant phenomena includes passings and the variation of placement of the heavenly bodies in relation to each other. So Aristotle says there would have to be more than one motion of the earth in order to account for the motions of the celestial bodies, because there isn't just risings and settings of everything with a fixed relationship, which is why the fixed stars are called that, because they always hold, their constellations always hold a fixed relationship, although they are hypothesized or theorized as really being all in motion together. We find everything else, the planets, the sun, and the moon, moving with various other motions. They're pulled rising and settings along with the fixed stars, but they move with a motion of their own through the zodiac. The motion of the sun through the zodiac has a variation north and south, whereas this common motion that we have been talking about of risings and settings is east and west, east to west, and not varying north and south. So we observe the sun through its course through the zodiacal belt or through the ecliptic, moving not just east and west, but straying to the north in the summer and straying to the south in the summer, so that the path of the sun is oblique. Now, in order to account for this second motion, there would have to be a second motion of the earth besides just turning north, besides just turning east and west to account for risings and settings every day. In order to account for the sun straying a great deal, a difference of about 45 or 50 degrees if you include how far north and how far south, there would have to be an equivalent and proportional motion of the other celestial bodies, of the fixed stars. For the Earth turning would have to be also tilting to account for the changing motion of the sun. For, mind you, the sun is hypothesized as motionless, and the fixed stars are hypothesized as motionless in Galileo's and other heliocentric theorists' viewpoint. And any apparent motion of the sun and any apparent motion of the fixed stars has to be attributed to the earth, to the motion of the earth. So the apparent motion of the sun that varies north and south throughout the courses of the seasons would have to be accompanied by a congruent and equivalent motion of the fixed stars north and south. But that is not observed. The conclusion being that, or rather the whole argument being that, since we observe passings and various movements, including this north and south movement of the sun, if the Earth's motion is to attribute, if the Earth's motion is to account for the observed apparent motion of the celestial bodies, then the Earth would have to move with more than one motion. However, the Earth moving with more than one motion, more than just rotating east and west to account for risings and settings, would result in the fixed stars rising and setting over different latitudes, north and south. But there is no variation of the fixed stars north and south. Rather, the same stars rise and set over the same northern and southern latitudes. Galileo then has to answer this, and that is why Galileo spends a great deal of time in his dialogue concerning the two chief world systems, trying to address this problem, because he knows that many Aristotelians at his time pointed exactly to this problem. And he had to address them and resolve the problem. And you will find that Galileo largely admits the conclusion that yes, there would have to be some variation of the fixed stars north and south if the motion of the Earth is to account for the apparent motions of the sun and the fixed stars, because the sun has not just one motion. And if the Earth is to account for the motion of the sun, and the sun has more than one motion, then the Earth must have more than one motion. And that motion would also result in more than one motion of the fixed stars. Yet we do not observe the fixed stars to move with anything but a single invariant motion, rising and setting over the same northern and southern latitudes. Galileo largely admits the conclusion, yes, there should be a variation north and south of the fixed stars. And no, we don't observe that. You will find that he rather evades the force of the conclusion. While admitting the conclusion and admitting the argument that was originally from Aristotle's On the Heavens, which I expanded upon, and which Simplicius had expanded upon, that Galileo affirms the conclusion. He admits, he practically confesses, because mind you, this is set during the Inquisition. He largely confesses, admits, affirms the conclusion that we see that the fixed stars should appear to vary north and south if the Earth is to account for the apparent motion of the heavenly bodies. And we don't observe that. The way he evades the force of the conclusion is by saying that the fixed stars are so distant from us, that they're at such an incalculable distance that the observation of their change would be difficult. And actually, their variation north and south that would be attributed to the Earth's motion would be so scant, would be so minute, that it would be difficult to observe. He says, we just haven't observed this yet. Although, mind you, for ages upon ages, humanity has known, even amongst uneducated folk communities, that the northern pole is fixed, that the northern celestial pole at the tail of the lesser bear is fixed and completely unmoving, which would not be the case. That would have to vary north and south throughout the course of the year, which it does not. So Galileo says, well, since the fixed stars are so distant, the variation that results, that we should observe some apparent motion amongst the fixed stars that corresponds to the sun's variation north and south. But that motion, since the fixed stars are so far away from us, would be difficult to observe because it would be minute. And then he says, perhaps we haven't observed them, for one, because people have not known what to look for. And this minute variation in their northern and southern positions would be difficult to observe if we weren't looking for that. And secondly, and worse, he says that if we had the proper scientific equipment, if we invented more precise telescopes, then we could observe the phenomena. So that a phenomena is there, which it would be if the Earth were in motion, but we don't observe that phenomena, which is the Aristotelian argument. And Galileo says, well, we would if we had the right equipment and we knew what to look for. So if you read Galileo's dialogue concerning the two chief world systems, if you read that closely, you find that besides misrepresenting the Aristotelian arguments, besides misrepresenting the geocentric arguments, he admits their conclusions because he has to keep focusing on the part of their arguments that he knows he has to resolve in order for his view to take hold. And while misrepresenting their arguments, he still ends up admitting their conclusions with this qualification that those observations just haven't been noted, but they would be there. And in future times, when we develop the right kind of technology, we'll make those observations, and that will be a great achievement of science. That is what he says. And I provide the footnotes that are excessive in order to show that The things that I show Galileo as saying are the things that he wrote in his dialogue. And many of the arguments that I have Simplicius of Cilicia say are arguments from Aristotle's on the heavens, which have merely been inserted as proposition, answer, conclusion, instead of being a tightly wound, self-reflective refutation of different views and taking the relevant ones about the heliocentric model, which Aristotle addressed, because there were people saying that kind of stuff when he was alive. When he was alive, he's a daimon. So I will read the end of book 2. This will conclude the cosmological focus. And mind you that Galileo's responses are provided many times verbatim, and that Galileo referenced Aristotle's arguments verbatim. The ones that I have used, the central argument that I have shown, he referenced verbatim. And then he admitted the conclusions with the qualification of a progressive the progressive lover of technology and of advancement and hatred of antiquity. I should say that the scientists were always that obnoxious. As they are now, as they are with their subjectivist and relativist quantum mechanics. People like Galileo were as obnoxious as quantum mechanics professors, arguing over who can make the most subjective theory, who can make physics the most subjective. That was the sort of personality and character that Galileo probably had. Of a quantum mechanics professor trying to argue with other quantum mechanics professors who are the only ones in a physics department about who can make the most subjective theory about physics, about who can push relativity further into subjectivism, and then writing about each other's writings, all essays, writing about somebody else's essay about somebody else, which references somebody else's essay to try to point out the most and produce a more subjective interpretation of physics, instead of arguing about whether or not motion is discrete or continuous, whether or not moving things are, motion is discrete and skips from stages, or is continuous and infinitely divisible. If they mulled over that, they wouldn't be preoccupied with arguing over who can make the most subjective theory about things that are least receptive of subjectivity. But you see in this, where relativity has a sort of place, but not the kind of relativity that Einstein and these modernists argue for. Relativity in the sense that there's a motion, there's something to be accounted for, and the motion is apparent and is relative in the sense that if you're moving, you observe other things to be moving in the other way, or you observe everything else to be moving in the other way. But that motion is real, and that motion is attributed to one or the other and not both. And Galileo wasn't that far into it, misunderstanding to know and to state very clearly in his dialogue that the motion we are after has to be one or the other of them. This relative motion of an observed motion that could be attributed to the things that are observed to move, or could be attributed to the thing that is in motion that is separate from them, and those all moving being attributed, or those all appearing to move being attributed to the sailboat, for example. But that motion has to be attributed to one or the other and not both. Okay, I will continue with this reading. Simplicius of Cilicia. I would gladly turn the conversation back to the point where we left off, for these other problems are but particulars, which would require yet others to revolve around to a conclusive demonstration of an affirmation of one or the other of our perspectives regarding the arrangement of the cosmos. How then do you propose to go about resolving the problem I set you? Galileo. As I said, there are a few avenues which I consider likely to unravel the problem without inhering contradiction. The first I mentioned before, that the poles, the axis, the equatorial plane, and the parallels referred to as latitudinal lines, all these things are in the earth and not in the stellar sphere, that being immovable and devoid of all such things. It is only in imagination that they can be pictured there by prolonging the axis of the earth to where its termination would designate 2 points placed over our own poles, and extending the equatorial plane to that, there would appear to be a circle in the sky corresponding to it. Now, if the true axis, the true poles, and the true terrestrial equator do not change on the earth so long as you stay on the same place of the earth, you may take the earth elsewhere, wherever you please, without ever changing your own location with respect to the poles, or to these circles, or to any other terrestrial thing. And as you do not change place with respect to the earth's poles yourself, that is in such a way as to raise and lower them, likewise, you will not change place with respect to the poles imagined in the sky, so long as we mean by celestial poles those 2 points which would be marked by the terrestrial axis when prolonged in the sky. It is true that such points in the heavens are changed when the transposition of the earth is carried out in such a way that the axis points to other parts of the immovable celestial sphere. But our situation with respect to them would not be changed, so that no one would be elevated more than the other. Whoever wants one of the poles in the firmament corresponding to the earth's poles to move upward and the other downward must simply travel along the earth towards one or away from the other. Nothing is accomplished by transposing the earth and ourselves along with it, as I have said. Simplicius of Cilicia. You seem to me to be saying two different things. I have already addressed your claim that there is no substantial basis for the celestial poles, which you say are imaginary extensions of the axis of the earth projected to the firmament. I ought to repeat that regardless. The problem at hand is to account for the apparent motion of the fixed stars, which would sway north and south if, like you say, the firmament and the sun are both motionless, and both of their apparent motions have to result from and be caused by the earth's own movement. In all cases, the celestial pole appears to be unmoved and fixed directly over the axis of the earth, which is inevitably part of the formula required to determine which of the two, the earth or the sun, is in motion and which at rest. Your statement that there is no reality to those parts of the heaven should be referred back to the first part of our conversation. Besides that, you say that the transposition of the earth throughout the cosmos does not and could not affect the apparent position of the poles and circles of latitude imagined in the sky, so long as you don't change your position on the earth. I must overlook this rash statement and draw attention to your other remark. You say that, in contradiction to the prior statement, that such points in the heavens are changed when the transposition of the earth is carried out in such a way that the axis points to other parts of the immovable celestial sphere. And if I understand at all your meaning, you fall back into the alternate contradictory again when you claim that only by traveling along the earth toward or away from the poles of the earth do the celestial poles appear to move upward and downward in the sky. First, do we agree that the apparent motion of the fixed stars is one of the elements of the problem? I wish to avoid your writing off the structure of the heavens as illusory, as toiling over that would only distract us from the problem we are already involved in. Galileo. You may overlook that statement, however, that is at the root of our disagreement. Simplicius of Cilicia. Then for now, we have the task set in front of us to account for the apparent motion of the heavens, along with that of the sun, in question of whether the motion of the sun or the earth is responsible for them. For we agreed that one of the two must be the cause of those apparent motions. Be good enough to answer if you agree with this. I do not think that you would deny to me that if we were to travel only 60 miles to the north along the face of the earth, the celestial pole would rise 1 degree. And likewise, another 60 miles to the north, the pole would raise up another degree for us. Galileo, such a pattern of our movement in increments of 60 degrees would in 60 miles would result in observing the northern celestial pole to be raised up a single degree each time. Yes. And again, that is about moving on the face of the earth. That if you move towards the north, the northern celestial pole appears further up in the sky. Simplicius of Cilicia. There is much change indeed in the stars which are overhead, and the stars seen are different as one moves northern and southern. There is much change indeed in the stars which are overhead, and the stars seen are different as one moves northward or southward. For there are some stars in Egypt and in Cyprus which are not seen in the northerly regions, and stars which in the north are never beyond the range of observation, which never set. In those regions, in the more southern regions, they rise and set. Now, if such minimal change in our position to the north or south on the earth causes a manifest alteration in the horizon, I mean, if moving toward or away from the celestial pole a mere 60 miles upon the surface of the earth produces such an effect on of the apparent motion of the pole star, as well as on the northward and southward positions of the rest of the fixed stars, then wouldn't even the slightest rotation or tilt of the earth, resulting from its oblique orbital path, likewise result in an obvious change in the position of the northern celestial pole star Polaris? Galileo. Not if the distance is so great between the fixed stars and the earth that the orbital path of the earth around the sun is rendered null. If the cosmos is infinite, no fixed ratio could determine a correspondence between the path of the earth through its orbit and the fixed stars. Simplicius of Cilicia. Leave off this divergent consideration about whether or not the cosmos is infinite. If you wish, I will prove the contrary to you afterwards. We ought to reach an agreement about concentric circles before considering what amount of distance would render the motion of one body within another as having no effect. Galileo. Then let us continue with the speculation about concentric circles, if that isn't also a divergence. Simplicius of Cilicia. No, that is not a divergence. We will need use what we gather here in what folds from the same problem. Consider if, with concentrically described circles about the same center, the innermost, consider if, with concentrically described circles about the same center, the innermost and outermost circumferences, regardless of their distance, trace out the same 360 degrees. Or if you suppose, on the contrary, that a larger circle contains more angular space than a smaller circle, and that they both don't contain an equal angular space to 4 right angles. Again, consider if, with concentrically described circles about the same center, the innermost and outermost circumferences, regardless of their distance, trace out the same 360 degrees, or 4 right angles. Or if you suppose, on the contrary, that a larger circle contains more angular space than a smaller circle, and that they both don't contain an angular space equal to 4 right angles. Galileo, a greater circle contains the same amount of angular space as a lesser circle, and no more. That is right. Simplicius of Cilicia. Then tell me, concerning concentric circles, if the innermost circle revolves around, bringing a point along its circumference to a position at right angles to that point's original position, does that quarter turn of the lesser circumference also cover a quarter of the total angular space contained by the greater circle with the outermost circumference? Galileo, a quarter turn of the innermost circle would cover the same amount of angular space as a quarter turn of the outermost circle. Yes. Simplicius of Cilicia. And if 2 points are aligned at the same degree of each of the circumferences, one on the innermost and one on the outermost, does a half turn of the lesser circle bring the point that was in alignment from conjunction with the point on the greater circumference to a position of opposition with the point it was aligned with? Galileo, yes. Simplicius of Cilicia. And the point on the lesser circumference will have covered half the angular space of the greater circumference as well as its own by reaching the position opposite to the point on the greater circumference. Galileo, yes. Simplicius of Cilicia. And will have thereby covered the same amount of angular space contained by the greater circumference as it covered within its own circumference. Galileo, that is right. Simplicius of Cilicia. Then a 47-degree rotation of the Earth would turn its axis an equal amount of angular space contained within the sphere of the fixed stars, from whatever star it aligned with previously to a star 47 degrees away from that. Is that agreeable? Galileo, if the Earth were shown to rotate thus, that would be the result. Simplicius of Cilicia. And if, along the annual course of the Earth around the sun, which is oblique to the axis of the Earth and the equatorial line, the axis of the Earth is brought around to point away from the northern celestial pole, would that not result in an obvious change in the apparent position of the northern celestial pole? Galileo, if that were the case, yes. Simplicius of Cilicia, especially if moving 60 degrees north or south results in a change of the altitude of the celestial pole by 1 degree, especially if moving north or south along the face of the Earth results in a change, especially if moving 60 miles north or south along the face of the Earth results in a change of the altitude of the celestial pole by 1 degree. There would be a considerable change in the apparent altitude of the celestial pole if the axis of the Earth were to be displaced to point elsewhere along the Earth's annual course while moving at an oblique line. especially if moving 60 miles north or south results in a change of the altitude of the celestial pole by 1 degree. There would be a considerable change in the apparent altitude of the celestial pole if the axis of the Earth were to be displaced to point elsewhere along the Earth's annual course while moving at an oblique angle to its axis and to this equatorial line. I should remind you that we observe no displacement of the celestial pole from Stella Polaris. Galileo. Yes, however, you are mistaken about the magnitude of the apparent variation in altitude of the pole star. Wouldn't a greater circumference require a greater distance to be traversed in order to result in the same difference in angular space than would a lesser distance traveled around a greater circumference? Simplicius of Cilicia. Well, as glad as I am that you have come around to agree with me that a slight rotation, tilt, or change of direction of the point of the Earth's axis during its annual course around the sun would result in an obvious change in altitude of the pole star and the rest of the fixed stars. I am unsettled by your posing an opposite problem for me. From the opposite perspective, I feel as if I am being sent out to hunt rabbits. Before you argued that the movement of the Earth around its center would result in no apparent change in the latitudinal risings and settings of the fixed stars because of the difference in magnitude and the great distance between the Earth and the fixed stars. Now, you argue that a movement along a greater circumference, the orbit of the Earth around the sun, would result in less apparent change in the altitude of Stella Polaris for the reason that the same distance covered along a greater circumference corresponds to less angular degrees than that distance covered along a lesser circumference. My argument, however, requires no such resolution regarding these new problems. I have only set out to argue that there must be an obvious apparent change in the altitude of Stella Polaris if the axis of the Earth points away from that star during its annual course obliquely around the sun. Thus, if the movement of a ship a mere 60 miles makes a fixed star rise 1 degree from me, why shouldn't a similar change, and even a much greater one, happen for me when a ship is transported towards the same star by such a space as the diameter of the Earth's orbit, which you must agree is double the distance of the Earth from the sun? Galileo. I suppose I will make a concession to some of these particulars, but without renouncing the Copernican worldview. And this, mind you, is much his admission. This is Galileo's beginning to admit the conclusions. I suppose I will make a concession to some of these particulars, but without renouncing the Copernican worldview. I have been influenced by knowing that the annual movement attributed to the Earth by Copernicus, if made perceptible in the stellar sphere, would not produce visible alterations equally among all the stars, but would necessarily make great changes in some, less in others, and still yet less in others, and finally none in some stars. The alterations which would be seen then are of 2 sorts. One is an apparent change in size of these stars, and the other is a variation in their altitudes at the meridian, which implies as a consequence the varying of places of risings, settings, distances of the zenith, etc. Simplicius of Cilicia. Please don't bother me about the apparent change in size of stars, because I don't wish to fall back into our intermediate argument again. Go on about the variation of altitudes, places of risings and setting, and the distances from the zenith, our current topic, which I assume you will try to resolve. after denying as far as you possibly could that those things would result from an arrangement of the cosmos with the earth moving around the sun. Galileo, I told you that I don't think this problem has been thoroughly considered. I told you that I don't think this problem has been thoroughly considered. I'll provide a detailed explanation of the phenomena that we should expect to see under the hypothesis of the Earth's annual motion around the sun, much of which you have already explained. Then I will say why those apparent motions in the positions of the fixed stars have not been observed. Again, I will provide, says Galileo, a detailed explanation of the phenomena that we should expect to see under the hypothesis of the Earth's annual cycle around the sun, much of which you have already explained. Then I will say why those apparent motions in the positions of the fixed stars have not been observed. For I think that I can either show that those effects are too minute for observation, or that they could be observed, but only with great difficulty. This then is my personal attempt at a solution. Before which, I will provide an overview of the motions of the Earth that are responsible for the peculiar results in question. There are the annual and the diurnal motions of the Earth. The former, the annual, must be understood to be made by the Earth in the circumference of its orbit, which is a large circle described in the plane of the ecliptic. The other, the diurnal, is made by the Earth's globe upon itself, around its own center and axis, and not vertical to the plane of the ecliptic, but inclined to that with a tilt of 23.5 degrees, which inclination is maintained throughout the year. And what must be especially noted is that it keeps this tilt always turned toward the same part of the sky, so that the axis of diurnal motion is maintained always parallel to itself. Hence, we imagine this axis prolonged all the way to the fixed stars, and while the Earth is going around the whole ecliptic in a year, this axis describes an oblique cylindrical surface, which has for one of its bases a said annual cycle of the Earth around the sun in orbit, and for the other, a similarly imaginary circle traced by the extremity, or let us say its pole among the fixed stars. This cylinder is oblique to the plane of the ecliptic according to the inclination of the axis which describes it. And this, we have said, is to be 23.5 degrees. This remains perpetually the same, except for some small variation in many thousands of years, which is not significant to the present connection. Thus, the terrestrial globe neither tilts further nor straightens up, but is kept immutable. Now, I say first that none of the fixed stars in the ecliptic will ever vary in elevation, no matter what motions the Earth makes in the plane of the ecliptic, but will always be perceived in the same plane, through which now, I say first that none of the fixed stars in the ecliptic will ever vary in elevation, no matter what motions the Earth makes in the plane of the ecliptic, but will always be perceived in the same plane, though they will approach and recede from the Earth by as great a space as the diameter of the Earth's orbit. Then, I say that the alteration of appearance, which, using the proper technical term, we may call the parallax of the fixed stars, is greater or less accordingly as the stars observed are more or less close to the pole of the ecliptic. And that finally, for stars on the ecliptic itself, the alteration is reduced to nothing, or the angle of difference of the pole star is the maximum. of the others. Those closest to this maximum are larger than those more distant from it. What he is saying is that the apparent motion of the fixed stars that we should observe is greater for the stars closer to the poles, and that closer to the equator and closer to the ecliptic, which runs oblique with the equator, the variation would be minimal. Again, the elevation or lowering is nil for stars along the ecliptic and large for those encircling the pole of the ecliptic, being intermediate for those in the middle. It is possible, Copernicus declares, that the immense distance of the starry sphere makes such small phenomena unobservable. And as has already been remarked, it may be that up to the present they have not even been looked for, or if looked for, not sought out for in such a way as they need to be. That is, with all necessary precision and minute accuracy. It is hard to achieve this precision, both on account of the imperfection of astronomical instruments, which are subject to much variation, and because of the shortcomings of those who handle them with less care than is required. Now, I have worked out a sufficient mathematical demonstration of what we should expect to see, that there would be a greater alteration in the latitudinal markings of some stars than in others, due to the Earth's annual course around the sun. If you would like to hear it, I will describe in detail what we should expect to find resulting from the hypothesis of the Earth's motion around the sun. Simplicius of Cilicia. Yes, please go on with your demonstration. Here, Galileo provides a mathematical proof, a geometrical proof of this sort of variations in the fixed stars that would result, this is his admittance, that would result from the Earth's motion around the sun. The Earth's motion should result in a greater distance of differentiation between the position of the pole stars than those along the ecliptic. This is somewhat irrelevant. However, I provided exactly what he wrote. From this, we conclude that the alteration of appearance, which we may call the parallax of the fixed stars, is greater or less accordingly as the stars observed are more or less close to the pole of the ecliptic. The angle of difference across latitudes is greatest for those stars verging on the polar region, while for stars on the ecliptic itself, the alteration is reduced to nothing. That is, the elevation or lowering is nil for stars along the ecliptic and large for those encircling the polar region, being intermediate for those in the middle. Again, the demonstration was taken directly without alteration from Galileo's dialogue. Simplicius of Cilicia. That is all well and good, Galileo. However, why do we not observe those apparent changes? That, remember, is my point. That if the Earth were to move around the sun, then we ought to observe the position of the fixed stars to alter across lines of latitude, north and south. Now, you have admirably demonstrated some particulars regarding what those apparent changes would amount to. Yet it is up to you to explain why they are imperceptible and pass unnoticed. Galileo. And my answer is that because the distance of the fixed stars from the Earth is so vast, the alterations just explained would have to remain entirely imperceptible in them, or if perceptible, then only by means of the right astronomical instruments. Again, these are quotations. As I said before, and as Copernicus declared, the immense distance, as I said before, this is Galileo, and as Copernicus declared, the immense distance of the starry sphere makes such minute phenomena unobservable. The immense distance of the starry sphere from us, from the earth, makes such minute phenomena unobservable. And it may be that up to the present day, they have not even been looked for, or if looked for, not sought out in such a way as they needed to be. That is, with all necessary precision and minute accuracy. It is difficult to achieve this precision, both on account of the imperfection of astronomical instruments, which are subject to variation, and by fault of their misuse. Besides which, it is almost impossible for the instruments, besides which, it is almost impossible for the instrument to be constructed absolutely accurately. For the scientific instrument to be constructed absolutely accurately and then maintain so is almost impossible. Ptolemy distrusted an armillary instrument constructed by Archimedes himself for determining the entry of the sun into the equinox. Again, Ptolemy distrusted an armillary instrument constructed by Archimedes for determining the entry of the sun into the equinox. He distrusted the instrument. Now, my idea is for us to make observations of the fixed stars with instruments which would require improving upon those currently available. And if in the course of these observations, any such variation shall happen to become known, and we have ascertained the annual motion, how great an achievement will be made in astronomy. Let me read this again. Now, my idea, this is Galileo speaking, is for us to make observations of the fixed stars with instruments which would require improving upon those currently available. And if in the course of these operations, any such variation shall happen to become known, and we have ascertained the annual motion of the earth around the sun, how great an achievement will be made in astronomy. Would you be convinced if those alterations really were perceived in the stars which seem to you so necessarily if the annual motion belongs to the earth? Would you be convinced if those alterations really were perceived in the stars which seem to you so necessary if the annual motion belongs to the earth? You must agree, if such a variation were perceived, nothing would remain that could cast doubt upon the Earth's mobility, since no counter could be found to such an event. Let me read this again. This is Galileo's Confession and Absurdity. Now, my idea is for us to make observations of the fixed stars with instruments which would require improving upon those currently available. And if in the course of those operations, if in the course of these operations, any such variation shall happen to become known, and we have ascertained the annual motion of the earth around the sun, how great an achievement will be made in astronomy. Would you be convinced if those alterations really were perceived in the stars which seem to you so necessary if the annual motion belongs to the earth? You must agree that if such a variation were perceived, nothing would remain that would cast doubt upon the Earth's mobility, since no counter could be found to such an event. Again, would you be convinced if those alterations really were perceived in the stars which seem to you so necessary if the annual motion belongs to the Earth? You must agree. If such a variation were perceived, nothing would remain that could cast doubt upon the Earth's mobility, since no counter could be found to such an event. Again, these are quotations from Galileo's dialogue. Simplicius of Cilicia. I think you have only made the task more difficult for yourself, Galileo. I wish to avoid letting the entire argument hinge on our disagreement about scientific instruments. I don't think that could be conclusive for either of us. We have agreed, have we not, about the properties of concentric circles and the equal angular space of a greater encompassing circle covered by a rotation of the lesser circle. Galileo. Yes, we have agreed to that. However, that is not entirely relevant to the axis of the Earth. If the axis of the Earth remains pointing towards the polar region in its course around the sun. For the circumference described by the Earth in its annual course does not correspond to the turning of a lesser concentric circle. If the direction of the axis of the Earth points to and is not pulled around the circumferential path of its orbit. Simplicius of Cilicia. Of course, the axis of the Earth remains pointing perpendicular to the equatorial line. And the path of the ecliptic runs obliquely across that, as you yourself say, and as we agree. Let us take your model of the relevant arrangement and phenomena. I refer to your description of a cylinder with its base as the circumferential path of the Earth's motion around the sun, and an equivalent circle described by a projection of the directional point of the Earth's axis throughout the annual course, equal to the base of the cylinder. I think our argument should resume that direction of thought. Galileo. Okay, go ahead. Simplicius of Cilicia. If the diameter of the Earth's orbit spans twice the distance as that between the Earth and the sun, and the axis of the Earth would point to and carve out a circle around the celestial pole that would be equal in area to the Earth's orbit, then we should expect to find that the celestial pole shifts as much as the span of the circumference of the Earth's orbital path, which is twice the distance of the Earth from the sun. Is that right? Galileo. Yes. But that might cover a minute and fractional area of the celestial sphere, the fixed stars being at such a great distance from us. Simplicius of Cilicia. Well, we agree that the axis of the Earth would be brought to point the width of an angle of some degree of distance around the outer circumference of fixed stars, while revolving around the inner circumference of the Earth's orbital path around the sun, even if, as we agree, the Earth's axis remains fixedly pointed perpendicularly to the equatorial line and traces a path oblique to that. Right? Galileo. Yes. Simplicius of Cilicia. Wouldn't also the circumference traced by a projection of the Earth's axis along its orbit have a diameter that covers a portion of angular distance along the circle inscribed to the fixed stars north and southward that is equal in area to the diameter of the Earth's orbital plane? Galileo. Yes, but we don't know what the angular distance would be. Simplicius of Cilicia. Well, if traversing 60 miles north or southward along the face of the Earth results in 1 degree distance in the altitude of Stella Polaris of the North Star, and we consider the diameter of the circle traced by the projected axis of the Earth as having an angle proportional to that, the result will be some definite amount of angular distance between the points of variation of the celestial pole. We have yet to agree whether such variation would be enough to be observable, however. Galileo. Yes, that is our current dilemma, Simplicius of Cilicia. Well, if we weren't attempting to observe the northern celestial pole, whether that changes its position or not, and we were attempting to track the alteration along latitudes of some other star, I would be less adamant about the observability of the apparent change under hypothesis. For one, as the rest of the stars appear to circle around Stella Polaris, that star provides a sort of anchor, being unmoved and encircled concentrically by the paths of each of the other stars, so that the northernmost constellations that never appear to dip beneath the horizon trace out parallel circles further or closer to the pole star in proportion to their latitudinal difference from their distance away from that point. So our observations don't have to rely on the lines of latitudes of the Earth and risings and settings thereupon, but can be observed without reference to any of that. Then also, we have more than just a single point to track, as the northernmost constellations, not just the pole star alone, would be seen to vary and be much more obvious, as Stella Polaris is the end point of the tail of Ursa Minor, and the circling paths around Stella Polaris are perfectly arranged such that the northernmost constellation, Ursa Minor, with the shape of a bear, appears to rotate around the end of its tail. If the celestial pole were to be displaced from the end point of the tail of the lesser bear, that whole constellation would appear to be thrown off from its path. And since that motion referred to is daily, and each night we have the chance to watch the lesser bear turn around its tail with its head tracing the outer circumference, and the question of variation of the celestial pole would be over the course of a year, resulting in the greatest distance between variant points at the halfway points of the year. We should see if the Earth moves around the sun, Ursa Minor spinning for half of the year, not around its tail, but around a point somewhere closer to the front of its body, making the end point of the tail revolve around that, so that the head and tail would both revolve around the hind legs or forelegs, for example, at the opposite end of the year. And such variation of the revolving spin of Ursa Minor be easily observable and would accompany the variation in the position of the celestial pole. That is, with our eyes fixed to the constellations around the celestial pole and not zoomed in through a telescopic lens to some star not considered as part of a constellation, the observation would be easily discerned, for great changes would occur in the motion of Ursa Minor, which would rotate not around its tail end, but its head and tail would revolve around somewhere between them, say the hind or forelegs. And as mentioned, we have no need for instrumental equipment to observe that a significant change occurs throughout the course of the year in the rotation of Ursa Minor. In some, there is a necessary alteration that would occur, a shift in latitudinal points of the fixed stars and especially the North Star, if the Earth is to revolve around the sun. But we observe no change. Again, in some, there is a necessary alteration that would occur, a shift northern and southernward. In some, there is a necessary alteration that would occur, a shift northern and southern. In some, there is a necessary alteration that would occur, a shift northward and southward of the fixed stars, and especially of the North Star, if the Earth is to revolve around the sun, but we observe no such change. You attribute the lack of apparent movement of the celestial pole to the great distance from us of the fixed stars, while admitting everything up to that point. Nonetheless, you agree that there would be some alteration in the latitudinal altitude of the pole star, which would not be unmoved as it appears to be, but would change throughout the course of the year. Your position seems more like an excuse than an argument, and therefore I am not sure how to deal with it. You say that if the earth revolves around the sun, there would have to be a change and variation in the position of the pole star. After which you say that there is no appearance of such an alteration because the distance of the fixed stars is so great. I admit that I am confused about your position more so than about the problem at hand. For our own position is that there would have to be an alteration in the position of the pole star if the earth did not. For our position is that there would have to be such an alteration in the position of the pole star if the earth did move around the sun, which, since there isn't an observable variance in the pole star, the earth cannot move around the sun. Again, for our position is that there would have to be such an alteration in the position of the pole star if the earth did move around the sun, which, since there isn't an observable variance in the pole star, the earth cannot move around the sun. You, however, grant us all of that, and then somehow elude our conclusion with the qualification that the resultant effects would be unnoticed, even if they would occur. You had better say that there would be no variation in the position of the pole star that results from the hypothesis that the earth rotates around the sun, than to admit all of that and then elusively say that they wouldn't or haven't been perceived. And you somehow think that such occurrences could be perceived with proper equipment after already stating that they are imperceptible. I am at a loss with contending against your position and have long considered the heliocentric model disproved. Again, you say that if the earth revolves around the sun, there would have to be a change and variance in the position of the pole star, after which you say that there is no appearance of such an alteration because the distance of the fixed stars is so great. I admit I am confused about your position more so than about the problem at hand. For our own position is that there would have to be such an alteration in the position of the pole star if the earth did move around the sun, which, since there isn't an observable variance in the pole star, the earth cannot move around the sun. You, however, grant us all of that and then somehow elude our conclusion with the qualification that the resultant effects would be unnoticed, even though they would occur. You had better say that there would be no variation in the position of the pole star that results from the hypothesis that the earth rotates around the sun, than to admit all of that and then elusively say that they wouldn't or haven't been perceived. And you somehow think that such occurrences could be perceived with proper equipment after already stating that they are imperceptible. I am at a loss with contending against your position, and I have long considered the heliocentric model utterly disproved. Galileo, I told you that the relevant phenomena haven't been thoroughly investigated. Simplicius of Cilicia. And you suppose that the motionlessness of the pole star hasn't been a primary topic of astronomical inquiry for ages upon ages? Galileo, perhaps not properly and not with the right instruments. Simplicius of Cilicia. Yet that star has guided every navigator of ships and is by common folk alike held to be the only unmoving star in the northern hemisphere. Yet that star has guided every navigator of ships and is by common folk alike held to be the only unmoving star in the northern hemisphere, Galileo. If, however, the alteration in the position of the pole star is barely perceptible, there would be no difficulty with their functional use of it as a sort of celestial compass. And yet, for strictly astronomical purposes, would be considered to be at variance in terms of altitude and latitudinal lines. Simplicius of Cilicia. As far as I am concerned, if the celestial pole has no apparent variation in altitude or latitude, then there is no such occurrence, which would have to occur if the earth rotated around the sun, as we agree. You at once admit both. As far as I am concerned, if the celestial pole has no apparent variation in altitude or latitude, then there is no such occurrence, which would have to occur if the earth rotated around the sun, as we agree. You at once both admit and deny that there is such an occurrence of variation in the position of the pole star. You say the alteration is virtually imperceptible, but prevalent nonetheless, and only noticeable, yet so far unnoticed, with scientific instruments which are not yet available. That is, you agree that there would have to be alterations along latitudes of the fixed stars if the earth moves around the sun. Again, as far as I am concerned, if the celestial pole has no apparent variation in altitude or latitude, then there is no such occurrence, which would have to occur if the earth rotated around the sun, as we agree. You at once both admit and deny that there is such an occurrence of variation in the position of the pole star. You say the alteration is virtually imperceptible. You say the alteration is virtually imperceptible, but prevalent nonetheless, and only noticeable, yet so far unnoticed, with scientific instruments which are not yet available. That is, you agree that there would have to be alterations along latitudes of the fixed stars if the earth moves around the sun. We say that since there are no such alterations observed, there is likewise no motion of the earth around the sun. You somehow then say that the alterations are minute and fractionable and imperceptible, yet admit they occur and that they must occur if the earth moves around the sun, after which you presume that they could be observed with specific instruments which are not yet available. Again, as far as I'm concerned, if the celestial pole has no apparent variation in altitude or latitude, then there is no such occurrence, which would have to occur if the earth rotated around the sun, as we agree. You at once both admit and deny that there is such an occurrence of variation in the position of the pole star. You say the alteration is virtually imperceptible, but prevalent nonetheless, and only noticeable, yet so far unnoticed, with scientific instruments which are not yet available. That is, you agree that there would have to be alterations along latitudes of the fixed stars if the earth moves around the sun. We say that since there are no such alterations observed, there is likewise no motion of the earth around the sun. We say that since there are no such alterations observed, there is likewise no motion of the earth around the sun. Then you somehow then say that the alterations are minute and fractional and imperceptible, yet admit they occur and that they must occur if the earth moves around the sun, after which you presume that they could be observed with specific instruments which are not yet available. Galileo. Again, I said this part of the problem has been hitherto uninvestigated, and not only by us, but future generations will have to reach a resolution in times distant from ours. Simplicius of Cilicia. Nonetheless, you admit that if the earth moves around the sun, there would have to be alterations in the latitudinal risings and settings of the fixed stars, and that there are no such phenomena observed. Galileo, and for the reasons I stated, that they are either minute and imperceptible or require more precise instruments. Simplicius of Cilicia. Well, if the motion of the earth around the sun would require visible alterations of the fixed stars. Again, if the motion of the earth around the sun would require visible alterations of the fixed stars, and especially the pole star, north and south across latitudinal lines. And there has been no such observations, but the pole star remains unmoved to all observers. Then doesn't it result that the earth can't move around the sun? Again, well, if the motion of the earth around the sun would require visible alterations of the fixed stars, and especially the pole star, north and south across latitudinal lines, and there has been no such observation, but the pole star remains unmoved to all observers, then doesn't it result that the earth can't move around the sun? Galileo. Not if they are imperceptible or their observation has not yet been discovered. Simplicius of Cilicia. If they are imperceptible, then there is no such occurrence. And the pole star and the rest of the fixed stars don't alter and aren't at variance across lines of latitude. And since such an occurrence would have to result from the hypothesis of the Earth's annual motion around the sun, but no such occurrence is observable, then the Earth doesn't move around the sun. The only position available to you, which I neither understand, is that such alterations have yet to be discovered. And even then, they ought to have been, if they occur at all. And if they don't, then the same result follows. The earth cannot be in motion around the sun. Again, if they are imperceptible, then there is no such occurrence. And the pole star and the rest of the fixed stars don't alter and aren't at variance across lines of latitude. And since such an occurrence would have to result from the hypothesis of the Earth's annual motion around the sun, but no such occurrence is observable, then the Earth doesn't move around the sun. The only position available to you, which I neither understand, is that such alterations have yet to be discovered. And even then, they ought to have been, if they occur at all. And if they don't, then the same result follows. The earth can't be in motion around the sun. Galileo. I should reiterate that I am treating this as an open problem, not yet investigated by Copernicus or anyone else that I am familiar with. I will put forth another attempt at a solution to this difficulty. There is a third motion of the earth. There is a third motion of the earth besides the diurnal and the annual motions. This is to keep the axis of the earth tilted and pointed toward the same part of the firmament. I'm going to tell you something which deserves your careful consideration. Far from there being any repugnance or difficulty in it, though it is opposite to the other annual motion. It is naturally suited to any suspended and balanced body you please, and without requiring any cause of motion. Such a body, if carried around along the circumference of a circle, immediately acquires by itself a rotation around its own center opposite to that which carries it around. And the speed of this is such that both motions will finish one revolution in precisely the same time. You may see this wonderful effect. You may see this wonderful effect, which suits our present purposes so well, by putting into a basin of water a floating ball and holding the ball in your hand. If you turn, I have to pause the video and read the rest of this after.